Hello, welcome to the channel. We have a classic NC173 National. This has had a full recap on there. We got loads of the waxes and a handful of resistors out of this thing, plus the can has been replaced. So this receiver is up and running, lights up, works on all bands, and it's been a really good restoration. The backstory on this unit, this lady came to me, my customer came to me asking if I could get this receiver to work for her. She was given to her by her late father, who was a ham, and this thing was made years ago, and she really just wants it to work so that she can use it and kind of foster those fond memories of her family, of her dad, and all those other things from the past. That she has great memories with this radio, and she wants to keep those things going. She'd like to try to get on the air. She does have a transmitter, a 20-watt transmitter that I'm restoring also. So between this and the Globe Scout, I think it's a Globe Scout Deluxe, the Globe Scout 20-watt transmitter, should be able to work some CW. Should be able to get on the air. So this is the receiver. Got some video of it listening off the air, and it works very well. Some of the backstory on National, the company was incorporated in 1914 as the National Toy Company, but by 1916 included household appliances and other products. The expansion led to a name change to the National Company, Inc. By 1923, the product line included toys, food mixers, radio components. Radio components were to play an important part in the company's growth in the mid-20s. As they moved into the large-scale manufacturing of capacitors, it was at this time that two engineers from Harvard University, Fred H. Drake and Glenn Browning, approached National Manufacturing to build components of their specifications for a radio of their own design. This construction of the Browning-Drake design, this set was capable of tuning the standard AM broadcast band only and could not achieve shortwave reception. By the early 1930s, National had established a reputation with the amateur radio community based on their lines of regenerative receivers, including the SW3 and SW5. In 1935, National introduced their top-of-the-line HRO receiver. This radio included 2 RF stages, crystal filter, and distinctive dial allowed. National began providing equipment to United States and Allied governments. Customers, which were Royal Navy in 1939. After the U.S. declared war in 1941, National was advised by the military to start building the HRO, and we'll tell you when to stop. National began producing for the war effort. The number of employees went from approximately 200 to about 2,500 during the war. The war effort brought increasing recognition and profits to National, and after the war and in the late 1940s, National went public. One of the famous aspects of this particular receiver is in 1947, a National 173 receiver went along with the Kon-Tiki expedition. Was a 1947 journey by raft across the Pacific Ocean to South America to Polynesian Islands by a Norwegian explorer. The raft was named the Kon-Tiki. The expedition carried an amateur radio station with the call sign LI2B, operated by former World War II Norwegian resistance radio operator. Hungain and Rabe maintained regular communication with a number of American, Canadian, and South American stations that relied on Kon-Tiki's status to the Norwegian embassy in Washington, D.C. On August 5th, Hungain made a contact with a station in Oslo, Norway, 16,000 kilometers, which is 10,000 miles away. Kon-Tiki's transmitter was powered by batteries and hand-crank generator and was operated on the 40, 20, 10, and 6 meter bands. Each unit was water resistant, used a 2E3 vacuum tubes, and provided approximately 6 watts of RF output, the equivalent of a small flashlight. So for now, we'll move on to the restoration and some of the video of this radio being brought back to life and going back to its customer to give them years of satisfaction and joy.
$1,000 in 2019, which isn't totally unusual for a nice home.
You pour it out. See this go? The realist. By the way,
That's the wide filter. Want to narrow it down and get to the CW? There you go. Excellent CW receiver on 20 meters. Picking through some of those seagulls. This is the National NC173 on the bench. The first note to make is there are dangerous voltages in tube radios. So if you're following along at home, you're doing so at your own risk. Please don't get inside these radios unless you know what you're dealing with and you know the voltages and the risks and hazard. You can be injured and these voltages can be lethal. There's over 200 volts inside here DC, so if you're following along at home, this is for entertainment purposes. And let's get into the alignment on the National NC173. So what I have on the screen is the oscilloscope is running with the sweep generator, and the marker at 453.0 kilohertz is the IF frequency. That's where the IF is tuned at this very moment. I've not done any adjustments on this radio. I've just got in here and got the equipment hooked up so I could see where the original IF is at. So one of the things we want to do is make sure that our IF frequency matches the crystal frequency. So when we narrow up the receiver and go to a crystal, go to one of our crystal narrow filters, as you can see here, it got smaller, we're on the same frequency. And the factory tune is still pretty good on this thing. It's right there. That's our first narrow filter. That's our first narrow filter. We go to the next filter. Didn't see much change there. Let's sweep through again. This is a little slow on the sweeps, but it definitely gives us a visual for what I'm doing. Go to the third filter. It drops down. It's a little narrower at the top, but the width on the bottom doesn't seem to change much. But as we can see, the peak frequency is 453.000 kilohertz. You go to the next filter. This one, we start getting an interesting look. It's got a little hump to the left. And I'm not seeing the filters really get that much narrower, but I do see a decrease in the level on the seagull. Because we can watch it go down. It was 34. This one, it's the next filter. It is a little narrower. It's down 38. Negative 38 on there on the spectrum analyzer. And that's filter number 5. So the key point here is that we get the IF alignment, and this is strictly, the beginning here is just the IF alignment. We get this so we can see that, we'll see if this hump can get squared away under the center here. That's what we're going to shoot for during this alignment. The next filter, filter 4. It has that a little bit too. I'll see if that goes away when I do my adjustments. Filter 3. it's a hair over a little bit on filter 3. I think it's somewhere in the adjustment. We might be able to see that getting that centered up where we don't have it off to one side. Filter 4. Looks pretty good. Filter 5. Which this is our wide filter. A little bit of decrease there. And then this is the full width. So let's see what we can do on our IF frequency alignment here. I have the NC173 on a Lazy Susan. I can spin this around a little bit. Let's see. I'm sure that's over there. I can spin this around a little bit and show you the inside. Where we're going to be adjusting is, I believe we're going to be here, 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 here. This is the first IF can, the second IF can. This is something with the AGC, and this is our beat frequency oscillator. There's not a lot to adjust as far as the IF, but we can definitely get something. Make sure this receiver is working to its best abilities. So, trying to spin it around the other way. I don't know if you're going to be able to, if it's going to stretch. Okay. Where am I tied in at? I am tied in right here. This is our mixer. I'm coming in on pin 5 on valve 2. Valve 1 is a RF. This is our antenna RF generator, RF amplifier. This is our mixer. This is our beat frequency oscillator and its associated components. This is our associated components for the mixer. I'm coming in on 5 with a sweep generator, and we've seen the spectrum analyzer on that. We're going to come through and tune this large can. I believe it has several components. It also has the switching somewhere buried in there. That was that large can on the front. So we should have 2 adjustments there. So like I said, I'm hooked into the grid on pin 5. And I'm hooked over to the output on this can, which is the second IF can. So this beginning part here is just for the IF alignment. So again, that's this part over here. Get a little light up here. These connections up here are the first can, and then this is our IF can, and the one back over here is the next IF can to be looking at. So let's see what we can get out of this thing and make sure this National 173 will be up to the task. One of the difficulties I'm having is I haven't seen in the instructions really a whole lot of specifics on how to do the alignment. There's not much in there. We can go, let's see. I got the manual here so I can know where different components are at. Again, L4 is the first IF can. This is our filter can, which our IF runs through there. And then L5 hooks to valve 2, which is the second IF. And then behind it is L8, which is connected to the AVC amp. So to do this, our AVC is turned off. And like I was saying, AVC amplifier alignment. The alignment data. We can see here alignment data. Realignment can be determined by checking the performance of the receiver. Come down here. The RF coil groups are mounted in aluminum compartments. Those are the cans, L1, L2, L3. HF oscillator and first detector coils have individual general coverage trimming capacitors, and the E band has a general coverage paddle capacitor 6. If the IF transformers, which is where we're at, crystal filter, AVC amplifier, and C number oscillator transformers, all have individual permeable tuned iron core inductors with screw adjustments for alignment purposes. These adjustments are identified on figure number 5. This is figure number 5. My test speakers hooked up to the receiver. Well, the basic alignments are to look at the audio signal, inject a signal into the receiver, adjust the associated cans for a peak in the audio signal. What I'm wanting to do here is make sure we do a visual on the IF, make sure the filters are going to work at their optimum. Get my favorite Craftsman screwdriver. And let's see if you see anything here on these first. Oh, that did change a little bit. So what I'm looking at is symmetrical here. I want to make sure these go up the same. I think this hump here is what I'm seeing on all those other filters. If I turn it down to one of the filters, where that was pretty obvious, like there. We are losing a lot of gain. Let's go back to there. Get our gain back. Let's see what this other one does. Go to the wide filter. Definitely move the top of that one. Okay, so you can see we moved the peak off of the optimum, off of our marker there, so. And then that's off. Again, we've shifted it off to this, off the peak where we're trying to peak it at that particular frequency that the marker's on. What I'm focusing on is making sure it's equal on both sides. The peak number is great, but having an even spacing on both sides will give us the best on the receiver. And I like that when the marker is dead center and it looks like a nice pyramid there. Yes, I got enough a little bit more. On this first slug, I'm not seeing. Yeah, we're getting a lot. It's gone off the page. Let me adjust my reference level here or turn the gain down a little bit. Now we're starting to shift to the other side. Turn it a little more, you'll see it's shifting this way. Going away from our peak, our center frequency. Here we go, we're gonna bring it back. There we go. Nice and even on each side. Let's turn this filter on. So this is filter 1. Let it fully sweep. We'll see what it would look like. There we go. Peaked out right on the marker. Filter 2. I don't know if it changed the width much. Again, there's the no crystal filter. Filter 1. There we go, filter 1. Go to filter 2, which is a hair wider than filter 1, but again, it still looks pretty nice, evenly sloped. Filter 3, a little narrower at the top. Filter 4, again, a little narrower at the top. And filter 5. Go back to wide. About 5.5 kilohertz wide. That is our IF filter and how it looks the way I got it tuned. Everything looks excellent. Got good balance. It's evenly sloped on both sides. For what we got, should work pretty good. Thanks for tuning in. Hope everybody has a great day, and we'll see you next time.